Last day is going to be something that is 100% completely review and should not take very much time at all. So thankfully, that's the case, since we only have 11 minutes. Okay? You should remember a really, really important vocab word called valence. Okay. Woo! Valence electrons. Okay. What are the valence electrons?
The most energy bound electrons. Outermost.
The outer energy level electrons. Okay. So what we did from an electron configuration standpoint is identify where all the electrons are. Right? Okay. The valence electrons are how many electrons are in the energy level that's the furthest away, or it's in the how many electrons are in the energy level that is got the most energy. Okay? So, if you remember, valence electrons typically need to be what for it to be stable? You guys remember? For an atom to be stable, how many valence electrons does it typically need to have? 8. It's called the octet rule. Okay, we're not going to get, I don't think we're talking about the octet rule today, but I'm just going to explain that. So here's the quick way to identify how many valence electrons they have, and it's simply just looking at the periodic table. Go figure, another thing you can just find out by looking at the periodic table. Okay? Now, a lot of times, there are two different methods you'll see with periodic tables. You'll see a method where the groups are numbered 1 through 18. There's another method where, like, these guys, this, and the S and the P are separate from your D block or your transition elements. Okay, so just be careful when you're looking at, maybe if you're looking at a different periodic table. But here's what we do. We're going to base valence electrons on what group they're in. So you can quickly look at the periodic table and identify how many electrons are in the outermost energy level by looking at the periodic table. Group 1. One valence electron. This whole group, if it's in this group, this vertical column, it has 1 valence electron. That means its outer energy level only has 1, no more. How about this one? 2. Now, the transition elements act a little bit differently, so we're going to ignore them at this point. I know it says 13, it doesn't have 13 valence electrons, it only has 3,
4, 5, 6, 7, 8.
Okay, how many valence electrons does this group have?
8.
8. And those guys are the noble gases because, so they have, if you remember guys, I know we're getting a little ahead of ourselves from stuff we learned when we were in physical science, but please pay attention. Where they're located on the periodic table tells us how many valence electrons they have. And 8 typically means it is stable. So the group 18, or the noble gases, they're stable for a reason. It's because their outer energy level is full. Okay? And remember, valence electrons are really important because those are the electrons that are involved in what? Bonding. Okay? So those are the guys that are going to bond, and they bond in a way that makes atoms stable. Okay? So, I want you guys to answer these 3. You should be able to do it quickly in your notes. You guys all should have your notes out. What?
Argon,
AR, CA, AL. Don't worry, next chapter you guys will get about 52 of them. Okay? I want you guys to put how many valence electrons each of these has. Now remember, is this total electrons?
No.
Not total electrons. Outer energy level electrons.
How do you say the third one?
Third one.
aluminum.
Woo!
Natalie, you done?
So we're not doing bonding this chapter. We're just doing condensation.
Okay. Natalie, how many does argon have? 8. Shelby, how many does calcium have?
2.
Yep. And Tyler, how many does aluminum have? 3. Yes. Pretty simple. Now, does this mean that aluminum has 3 total electrons?
No.
No. It has how many total electrons? 13 total electrons. Well, I thought this number was the proton number.
And electrons, because they're the same, because they have to be.
Unless it's an ion.
Okay, if we're talking about an atom, protons and electrons will be the same because atoms are what? Neutral.
neutral,
Yeah.
not stable necessarily.
Yes.
Okay, they're not, most atoms aren't stable except for the.
Neutral.
Okay? Alright, electron dot notation. You should remember this from physical
Oh, yeah.
science too. It's really, really easy. Essentially, we're just going to take the valence electrons and put them in a form that makes them easy for when we do Lewis structures, which we will do Lewis structures in a couple chapters. Just like we did in physical science. We'll do a little bit more difficult ones.
See, this is the stuff I remember.
Okay, when Safford was doing the electron dot notation on the board, he did like CA and then put the two together instead of on different sides.
Oh.
Is that how you're supposed to do it?
Naughty.
That's what I thought.
No, don't do it that way.
Yeah, we're doing
Okay.
a chemistry chapter in biology right now.
Okay, so electron dot notation. You can tell all group 1 has how many dots?
Wow.
Because it's representing what?
One
Outer
valence
valence.
electron.
One valence electron. And guys, being able, this is not overly difficult, but it's really important and foundational for what we're going to do with Lewis structures a couple chapters from now. Okay? All this has two. Notice, like Trinity said, calcium does not have that. And I'll explain what's wrong with this. It's not that it's wrong per se. It's just when you start bonding them, usually if they're paired up like that, they're not involved in bonding. Okay? And so usually we know how many bonds it has by how many electrons are not paired. And so do you see how, guys, listen, do you see how if you don't have them showing unpaired, how you would have no idea how to bond it?
Yeah.
Okay, we're gonna get to that later. I'm just making that statement now. Okay, so here's how I want you to, oops. Do I not have a place to go over?
It's after.
Is it after?
Yeah.
Okay. Well, then let's go over cation and anion. Then I'll give you an example of dot notation. You guys should have no difficulty with it. Okay, you should remember cations and anions. Okay, these are ions. What's an ion?
One that
Positively charged.
a charged atom.
A charged atom.
Oh,
Okay, can be positive, can be negative. If it's positive, we call it a cation because cats have paws.
That's so. This is just because whenever I think of cats, I just think negative.
That's how I remember. I think cats, I don't like them. They're negative, so the opposite. That's what I do.
I love dogs.
All right, I don't care for dogs either. Anions, negatively charged ions. Okay, so how does a cation become positively charged? Does it gain a proton?
No, it loses.
Does everybody hear me? Some of you are not paying attention. This is really important. Why can't it gain a proton?
Because that's just the identity element.
Yeah, it would be a completely different element because we said protons determine identity. And so if I got 14 protons, it can only be one thing. It can only be silicon. Can't be anything else. Okay, so for it to become positively charged, it would have to what?
Lose.
Lose some negative things. So let's say I've got a silicon 2+, which is not a stable ion, but that's fine. Protons, how many does it have?
Still
14.
Always 14, regardless of ion or atom. Now, if it were a atom, how many electrons would we have? If it were an atom, you would have 14, but it's not an atom, it's an ion. Okay? It's going to have 12 because I gotta have 2 more positive things than I have negative things in order to give me the 2+ overall charge. Okay? Does that make sense? If it were -2, does this become a 10?
No.
No, protons always stay the same. It's just now how many electrons do I have to have? 16, so that I have 2 more negative things than positive to give me an overall net charge of 2-. Yes?
It's just a negative with no number that means
Yeah, it just has a negative with no numbers assumed 1. Okay?
How do we notate that?
How do you what?
Notate that.
Notate that. We need notate.
Like with dots. How would we?
Oh, we'll do it. Okay? Okay, I'm gonna have you do these in a sec, but I'm gonna show you just one of them, one of the atoms, and I'm gonna show you one with a charge. Okay? So let's say I want to do the electron dot notation of gallium. No, let's do phosphorus.
let's do hydrogen.
Okay, let's do phosphorus. Electron dot notation starts by putting the symbol of what it is you're writing the electron dot notation for. So phosphorus symbol is P. Okay, here's how we do this. We first identify how many valence electrons it has, and all of you would say what?
5.
5. Its outer electrons, or the electrons in its outermost energy level, furthest away is 5. So I need 5 dots. Here's what you do not do. That's wrong. Okay? The reason that's wrong, all I'm going to say about that now is because later bonding is not going to be done correct if you do it that way. So here's how you do this. I don't care where you start, but it's kind of like Hund's rule, where you have to put 1 electron at every location before you go back and put a second. So there are 4 locations: north, south, east, west. I just start north usually. So 1, 2, 3, 4.
Since that's 5.
So then 5, I'm going to put 1 there. Could I have put 1 here and not there?
Yes.
Could I have put 1 here and not there?
No.
Yes, you could do all sorts of stuff as long as you make sure that you put 1 in every location before you put a second. Make sense? Now let me show you. I know you're wanting to leave. Stop, stop, stop. Let's say we want to do, let's stick with phosphorus, but let's go with a 2- charge. This is not stable yet. Okay? 2- charge. So let me put 2 over here so we have space. How many electrons are in its outer energy level now?
7.
7. Okay, it had 5, right? But what does this -2 tell you? It gained 2 more electrons. Guys, when you gain or lose electrons, it's always going to be done from the outer energy level. Because what would be the easiest to take electrons away from? The one that's furthest away from the atom, or the ones that are inside the atom, or closer to the atom, or the nucleus? Okay, further away. So we would go 1, 2, 3, 4, 5, 6, 7, and that would be done. Good. Okay? I know we didn't get to let you guys do this, but I think, does anybody
Workshop.
anyone struggling at all? Does this not make sense? Or
Wait,
everyone
why is there, what is that, 7?
Yep.
Where is my word?
But phosphorus is a
It has
5,
So you
but,
add
oh.
2.
Yeah, you have 5 outer energy level electrons. You gain 2 to become the negative ion. And it's always, when you gain or lose electrons, it's always given in the outer energy. We'll take it.
Chemistry.
Already passed it.
You're sort of half the class. This is Spanish. I already got 60% of this class.
Hey, that's a rent price. He's next to me, go get the
This is, oh yeah.
And you don't need to go to college, they show them by the